Today we use batteries for most things. Most pieces of equipment, from the very wristwatch on your wrist through to the computer, will require some sort of battery backup to store information. Now, Ericsson equipment, whether it be radio base stations, switches, networking, they require to have battery backup, and they require fairly heavy batteries. Now, the lead-acid battery in principle hasn't changed much since it was invented by a Frenchman in 1859. And they only deliver around about 35 watts per kilogram, so you need a lot of battery in a large space. But they can supply a lot of current, which is what we need, especially in things like radio base stations. Basically, they involve lead, they involve acids, and the acid is usually a liquid, which means that you can splash it. The batteries themselves are called vented or flooded, and these are the batteries you'll find in your car. Obviously, we want to avoid these in Ericsson radio base stations and switches. What we're using is the maintenance-free or the sealed lead-acid battery. The actual designation is the valve-regulated lead-acid, or the VRLA. There are basically two types of VRLA battery. There's the absorbed glass matte battery and the gel battery. We almost exclusively use the gel battery in Ericsson equipment. What it does, it recombines the gases to reform a liquid, which of course moisturizes the gel once again, which means you don't have to keep putting water or acid in the battery throughout its life. It also reduces the pressure, because we want these unattended and we can't have batteries exploding, so we have a valve in there which releases any gas and prevents pressure building up inside the battery. For you as an installer with a radio base station, you would have an enclosed space, and so you will require to have a tube to vent the gas through to a nipple on the outside of the cabinet, and that way you do not get a build-up of explosive gases inside the cabinet. If you're working on an exchange or a switch, then it would be in a room that is already reasonably well ventilated. Now, I said that batteries generate heat. This means, of course, they're going to get hot. And this situation gets worse if you stack several batteries side by side. The heat can't get away. So the installer will have to put these distance pieces between the batteries. They just stick onto the side of one of the batteries here. In addition to this, we also have a temperature sensor, and this allows the microprocessor in the base station or the switch exchange to sense the battery temperature and make appropriate adjustments. This is stuck onto the side of the battery and the sensor fits in it.